Hey everyone, and welcome back to CodeMechanic. Today, we're diving deep into another critical engine sensor, the Manifold Absolute Pressure Sensor, or MAP sensor for short. You might be thinking, didn't we just cover the mass airflow sensor? We did, and that's a great point, because these two sensors often get confused. But they play very different roles in telling your engine's computer what's going on. So, let's clear up that confusion right now. The MAP sensor's job is to measure pressure, specifically the pressure inside your engine's intake manifold. Why is this important? Because that pressure is a direct indicator of engine load. Think about it. When your engine is just idling, the throttle plate is mostly closed, creating a strong vacuum in the manifold. This means low pressure, but when you stomp on the gas pedal, the throttle opens wide, allowing more air to rush in. This reduces the vacuum and increases the pressure inside the manifold. The MAP sensor detects this change and tells the ECU, hey, we're under a heavy load now. The ECU then adjusts the fuel injection and ignition timing to give you the power you're asking for. So, how does a MAP sensor differ from a mass airflow or a MAF sensor? A MAF sensor measures the volume and density of the air entering the engine, essentially telling the ECU how much air is coming in. A MAP sensor, on the other hand, measures the pressure of that air, which is an indicator of how hard the engine is working. Some engines use both sensors for a more precise picture of what's happening, while others, particularly speed density systems, rely solely on the MAP sensor. Now, let's talk about what happens when things go wrong. If you see trouble codes like P0105, P0106, P0107, P0108, or P0109 pop up on your scanner, your MAP sensor is waving a red flag. These codes point to issues like a circuit malfunction, a performance problem, or the sensor signal being too low or too high. But here's a pro tip. Before you rush to replace the sensor, check for the most common culprit: a vacuum leak, a cracked hose, a bad gasket, or a leaky brake booster can all throw off the pressure in the manifold. This tricks the MAP sensor into sending incorrect data to the ECU, leading to a rough idle, poor fuel economy, hesitation, and even stalling. So, how do we diagnose it? Start with a visual inspection. Look for any obvious cracks or disconnected vacuum lines. A smoke tester is your best friend here. It can quickly pinpoint the exact source of a leak. Next, you can use a multimeter or a scan tool to check the sensor's voltage. At idle, you should see a low voltage reading, typically around 1 to 1.5 volts, corresponding to high vacuum. When you snap the throttle open, that voltage should jump up to around 4.5 volts as the vacuum drops. If the voltage is stuck high or low, or doesn't change with the throttle, you might have a faulty sensor or a wiring issue. Remember to also check the sensor's reference voltage, which is usually a steady 5 volts from the ECU, and ensure you have a good ground connection. Sometimes, the problem isn't the sensor itself, but the wiring that connects it. Finally, if you do replace the sensor, calibration is key, while many are plug-and-play. Some systems may require a relearn procedure or an ECU reset to ensure the new sensor S readings are interpreted correctly. Always check the service manual for your specific vehicle. Understanding how the MAP sensor works and how to diagnose it can save you a ton of time and money. It is a small part that plays a huge role in your engine's performance and efficiency. I hope this helps you tackle those pesky MAP sensor codes. If you found this video useful, give it a thumbs up and hit that subscribe button for more deep dives into engine diagnostics. Thanks for watching, and I'll see you in the next one.